We see here rudder being rebuilt. I see the skin from which the original spar has been removed. We see the new spar and reinforcements assembly has been prepared. The reinforcements in the rudder rebuild consist of the use of a clip at the top. You see the clip section here at the top is used to get a good match in the length of the new spar to the length of the skin, since there's a lot of original manufacturing variation in the rudders. And the angle doublers, which were called for by the service bulletin, are added to the new spar in the area where the upper fitting will be attached. The fitting is over here along with the plates that are used in front of and behind the spar. The new hardware has been set out there. So those are the reinforcements at the top, which prevent further trouble up there. And then down at the truss, so where the horn assembly sticks up inside the rudder, we call this the truss, where that horn assembly goes up inside through the bottom rib, up inside, and then reattaches to the spar. This is an area where on many rudders, including late model rudders, the rivets across the face of the spar have been breaking through and cracking the spar due to torque overload. So what we've done in this area for reinforcement is to fashion a doubler panel which wraps around the spar so that the area where the truss attaches has been doubled. Then nut plates have been added to the steel of the truss so that we can attach radius blocks on the forward-facing web. And the radius blocks being machined to be a good fit to the flange bend radius and able to tolerate the torque loading so the radius block pulling in sandwich, pulling the spar against the steel of the truss, is able to tolerate the torque loading as the controls and the horn attempt to pivot the rudder. And the rest of the riveting here brings that back together. In the rebuild process, the original rib is reused, everything is reattached to that as appropriate. And then the new spar, rib, truss assembly is reinstalled to the rudder. Finished product is balanced and touch-up painted. All control surface rebuilds at Aerodyme, riveting, etc., checking alignment, are all done on steel fixturing. It holds the control surface in the appropriate control positions. So that when we're done, we have a surface that's either straight or, in the case of an elevator, may have the washout that it should have, which is usually to match its mate.